Good day, students! Today, we're discussing about set theory. A set theory is a fundamental part of mathematics that deals with collections of an objects called sets. Then, what is set? Set is simply a well-defined collections of distinct objects, which we call also the elements. For example, the set of natural numbers. And this is an example. The set of natural numbers. We also use special symbols to represent sets, such as curly braces. Sets are important because they provide a basis for understanding other concepts in math, such as functions, relations, and more.
And the next are the types of the set. And now let's talk about the different types of the set. There are several types. First is the finite set. Finite set contains a specific number of elements like 1, 2, and 3. And the next types of the set is the infinite set. Infinite set have an unlimited number of elements, such as the set of all integers. For example, z is equals to negative 2, negative 1, 0, 1, 2, 3, and so on and so forth. And the next is a null set or the empty set. This set contains number elements represent as null set or 0. And the next is a singleton set. This set contains only one element like A. Lastly, a universal set. This set is the set that contains all elements under consideration for a particular discussion or problem.
Next, let's tackle about the basic set operations. This includes the union, intersection, and the difference. So what is union? The union is an operation combines all elements from two sets. For example, if A is equals 1 and 2, and B is equals 2 and 3, so the A union B is equals 1, 2, and 3. Second is the intersection. The intersection is the operation finds common between two sets. Like for example, if A is equals 1 and 2 and B is equals 2 and 3, then the A intersection B is equals 2. Lastly is the difference. The difference of two sets contains elements that are in the first set but not in the second set. Like for example, if A is equals 1 and 2 and B is equals 2 and 3, then the A difference to B is equals to 1.
Now, let's talk about subset and supersets. A subset is a set where every element of the set is also an element of another set. For example, A equals 1 and 2, and B equals 1, 2, and 3. We say A is a subset of B. If A is a subset of B, but A is not equal to B, we call A a proper subset of B. A superset is the opposite. If all the elements of set A are contained within set B, then we say B is a superset of A.
Moving on, let's talk about cardinality, which is the number of elements in a set. If a set has a finite numbers of elements, its cardinality is just the count of those elements. For example, set A is equal to set 1, 2, 3 has cardinality 3, written as set A is equal to 3. For infinite sets like the set of all natural numbers, And we can count the elements, but we still talk about their cardinality, which is considered countably infinite. In contrast, some sets are uncountably infinite, like the real numbers between 0 and 1.
I'll explain some case set identities and laws. The first one is commutative law. It's the order in which we perform union or intersection doesn't matter, such as A union B equals B union A and A intersection B equals B intersection A. And the second one is associative law, as we can group elements in union or intersection however we like, such as open parentheses A union B close parentheses union C equals A union open parentheses B union C close parentheses. And the third one is distributive law. A set operation distribute over each other, like A intersection open parentheses B union C close parentheses equals open parentheses A intersection B union open parentheses A intersection C close parentheses. And for the last one is De Morgan's laws. These laws shows how the complements of union and intersection work, such as like open parentheses A union B close parentheses complement equals A complement intersection B complement, and open parentheses A intersection B close parentheses complement and A complement union B complement. These laws help simplify set operation and more complex problems.
Okay, so let's move on to the relations and functions of a set theory. But before that, we will define first what is a relation and function of a set theory. So first, the relation. So what is a relation? So the relation between two sets is a collection of ordered pairs where the first element comes from the one set and the second element comes from the another set. So, for example, relation of a set 1A, 2B, and 3C associate elements of a set 1, 2, 3, and a set ABC. So, for the function, so what is a function? So a function is a special type of relation where every element from the first set is related to exactly one element in the second set. So we say that A to B is a function from set A to set B.
The connection between set theory and logic. Set theory is closely related to a logic, particularly propositional logic. In logic, we use operations like and, or, and not, which have corresponding operations. The and operation is like intersection of set. The or operation is like the union of a set. The not operation is like a complement of a set. These operations can be visualized using Venn diagram, which are a great way to represent the relationship between sets.
Finally, let's discuss the application of set theory. Set theory is used in many areas of mathematics. It is a branch of mathematics that deals with the study of sets, which are collection of unique objects known as elements or numbers. Mathematics, it forms the basis of many branches such as algebra and topology. Computer science, set theory is crucial in database theory, search algorithms, and programming languages.
Now, set theory in real life. Set theory helps us in classifying things like organizing informations in databases and making decisions in probability, or even understanding relationships in social networks. So, we have another example of set theory in real life. So first, grocery in shopping. We can use set to ensure we buy everything on our list and not extra. And also, in social media, we can use sets to uncover hidden connections among our friends and groups, finding mutual friends or isolating those who are not in a particular group. And that's all the example and the uses of set theory in real life.
To summarize, set theory is a powerful and foundational concept in mathematics. It helps us understand the collections of an objects, the properties, the operations between them, and apply these ideas to various fields like computer science, logic, and more. Each of us has covered different aspects of set theory today, but together we've seen how sets, operations, and their properties form the building blocks of much of mathematics and logic today. And that is all. Thank you.